Hey everyone, we're going to take a look at exercise 42. I say 42, but actually it is 41. So let's just change that part up. 41. Let's take a look at 41. 41a, I think, is doable for all of you. I hope so, right? We have practiced quite a lot how to draw coordinate points. I think point P should be here. This is point P. Then we have point Q, 3 minus 1. So point Q is there. And we have R, 5,2. Which is going to be right there. Okay. Then let's see. No, it will work out. Okay, I was checking if something will work out, but it will work out. Okay, so that is A. Then at B. They say points PQR are vertices of parallelogram PQRS. Dus punten PQ en R zijn hoekpunten van parallelogram PQRS. Write down the coordinates of vertex S and draw parallelogram PQRS. Remember, if we name figures like this, we do it in order from anti-clockwise, right? So PQRS means S must be somewhere between P and R. Not literally in between, but it cannot be right here, for example. Then it would be PQRS. And then it goes right straight back to P, and then yeah, I cross my own figure. So if you find exercises like this difficult, the first thing that you could do is that you now connect P, Q, and R. The only thing what I now have to do is find point S. And they don't give you any new hints on how to do this, but here you have to use the properties of a parallelogram to find point S. Remember, in a parallelogram, opposite sides have equal lengths. So PQ must have equal length to a side that must be here. Not only that, they also have exactly the same direction. They are parallel. So what I could do two things here. I'm going to show you both methods. The first thing that you could do is say, well, this is a parallelogram. So those sides here should be parallel and equally long. So I could do it like this, measure it, it's around 3 centimeters, and then move it around in the same direction. And then I find that point S is right here. But if you have grid spaces like this, there is another way how you can do that, and you don't have to use your protractor. You can also just count the grid spaces, right? So you can see from Q to P, I go 2 to the left and 2 up. Or you can also say, seen from P, I go 2 to the right and 2 down. So if I want to have the same direction, I must go from point R, 2 to the left and 2 up. So point S must be right here. Oh, let's use a smaller font for that one. I said let's use a smaller font for this one, like this. And now I can draw this parallelogram. It will be like this. And you see from P to S is now always also parallel to Q to R. And you can also again count grid spaces. From P to S I go 2 to the right, 3 up. And from Q to R I go 2 to the right, 3 up. Okay? So if you've done this correctly, those edges are now going to be parallel. And here, those are going to be parallel as well. Right? Are we done? Almost. They also ask for the coordinate point of S. So S is going to be 3,4. So read carefully as well, right? Okay, then C. At C they say draw parallelogram PQTR. You can do this in the same drawing right here. What I would rather do, I think, is that I can even do it like this. Please wait for a second. I'm going to draw it in a new coordinate plane to make it a bit more understandable what I'm doing. Ooh, I don't like that he's doing it like this. Is this going to be okay? No. Why? Okay, let's do it like this. Oh, you're still pasting it right there? That's stupid. Okay, then let's do it this way. I will find a way, don't you worry. And then I just erase those manually right here. Rip. Let's keep point S there for a moment. I don't really need it. I know this is called PQTR. And again, it's very nice to now know why certain things are called certain ways. And before I'm going to explain it, I see I haven't aligned this perfectly. So let's first do that like this. Okay. Here I said this is called PQRS, which means that S must be between points P and R. PQRS. Here the tip is that I want us to draw PQTR. T is between Q and R. So that means I know I can connect P and Q. And PQTR means R is also connected to P again. That's not a nice line. That's better. And then it's actually almost exactly the same exercise as I did prior to this, right? So what you're going to do is you're going to try and find, and I already see this is going to be not that nice right here. What you're going to do is find sides from T to R or from Q to T that is parallel to PR and also parallel to PQ. So what I would do right here, I think, is I see P to R is 4 to the right, 1 up. So Q to R is 4 to the right, 1 up. So it must be right there. That's outside of my coordinate plane in this case. I don't mind that much if you find that your drawing is going to be a bit outside of your coordinate plane. If you want to, you could also now enlarge your coordinate plane, right? I could do this if I wanted to. And my coordinate plane is bigger. Call this X again. And then point T must be here. And again, as you can see, this is going to be parallel to this. And this here is going to be parallel to this. What I also could have done is say from point P to Q I go 2 to the right, 2 down. Here it's also 2 to the right, 2 down. Or I could have taken out my protractor right and then a line, for example, like this. So I'll align it like this and then move until it's easier now if I rotate it like this. Because then I can move over those parallel lines here. So what I could have done is rip this and then move downwards until point Q and then draw that line there that's equal in length to PR. So I first measure PR, it's around 4. If I measure around here, indeed I find point T there. If you don't have grids, you have to use that method, right, with the protractor. But if you have grids, then maybe this is a bit quicker to do. They don't ask us for the coordinates of point T in this case, so that means that now I am done. If you wanted to, you could have drawn them both in the same coordinate plane, but I think it's a bit nicer to draw them in 2 separate ones in this case. Okay? Good luck.